Good morning. As I told you in the previous video, I'm going to continue learning outcome 3.28. We are going to continue from page 4, question 7. If you take a look at the equations that we were given so far, they were all in the form of y is equal to plus or minus x. For example, here in question 5, we had y is equal to 4x. Question 4, we had y is equal to 7x. In previous questions, we had, for example, y is equal to minus 4x, y is equal to minus 3x, or y is equal to 5x. So they were all in the form of y is equal to x, okay, with a coordinate, with a coefficient with x, with a number with x. But there are other equations, okay, which are in the form of y is equal to plus or minus any number. For example, we can be given an equation of y is equal to 4 or y is equal to minus 2 without the x, okay? We can also be given x is equal to 5 or x is equal to minus 7, okay, without involving the y. So I'm going to work out question 7 as an example by referring again to the presentation like before, okay? So we are given these coordinates which are best written in a table. And we are asked, what do we notice? What do we notice about these coordinates that we are given? Maybe you might have guessed it right. All the x coordinates in each pair is equal to 2. Okay? All of them is equal to 2. If we plot these points, we notice that all the points lie on a straight line, which is parallel to the y-axis, to the vertical axis. In fact, the line that we have just plotted is vertical. I can list other coordinates which are on this line, like for example 2 minus 4, which is over here. 2 minus 4 is also on this line. 2, 4, which is here, or 2, 3, which is here, or 2, 5, okay, or 2, 10, which is even up there, okay. In fact, all the coordinates which have 2 as the x coordinate lie on this particular line, okay. And this line is called x is equal to 2. And you can notice where that name is coming from, okay? Because x is always 2. So it is called x is equal to 2. And it passes from x is equal to 2. Now we are asked to write two coordinates that lie on the line x is equal to minus 1. The most important thing to remember is in fact that x is equal to minus 1. So all the coordinates should have the x coordinate minus 1. Okay? Mela minus 1. It should pass from here. Okay? Because x is equal to minus 1. These points, as I already said, all have should all have the x coordinate minus 1, like for example minus 1 comma 2 or minus 1 comma minus 4, okay, and I can list other, for example minus 1 comma minus 2, minus 1 comma 4. Those are all points on that line. This line, since it passes from x is equal to minus 1, it is called x is equal to minus 1. Okay? Let's have a look to this very important slide. So all graphs of the form x is equal to c where c is any number. So c here can be any number. X is equal to 5, x is equal to 7, etc. Okay? Will be parallel to the y-axis. So this line here, it is on x is equal to minus 3. Minus 1 is here, minus 2, minus 3. So it is called x is equal to minus 3. This line, on the other hand, it is on 1, 2, 3, 4, 5, 6, 7, 8, 9. So this line is equal to x is equal to 9. And so are these lines. Okay, this line passes from x is equal to 10, so it is called x is equal to minus 10. Here the line, it passes from x is equal to 4, so it is called x is equal to 4. Okay? Let me go back to the notes, where I'm going to work the same question that I worked out on the presentation on the notes. So here we are again, page 4, question 7. Plot these points on the graph, and we need to plot these points. When x is equal to 2, y is equal to minus 5. So 2 minus 5, I'm going to plot them. 2 minus 3, 2 minus 1, 2, 0, and 2, 1. This is, as I told you, it is the same question that we have done on the presentation. And I'm going to join this line, which passes from all the points. Okay? What do you notice? We notice that the x coordinate is always 2. Mela, the x coordinate is always 2. The equation of this line is x is equal to 2, because it passes from when x is equal to 2. Part 2. Can you write two coordinates that lie on the line x is equal to minus 1? So x is equal to minus 1. So I'm going to write when x is equal to minus 1, okay, like this. And then I can use any other points for y. Okay, I'm going to use minus 1, 2 here, and minus 1, minus 3. It doesn't matter. Okay? Then part 3 is draw the line on the graph. To draw that line on the graph, it must pass from x is equal to minus 1, x is equal to minus 1 is here, so it must be parallel to the y-axis and passes through x is equal to minus 1. And this is the line, which is x is equal to minus 1. Okay? So this is question 7. Question 8 is in fact like question 7 that I have already worked out. Okay? Now I'm going to work out question 9 again by referring to the presentation. So again we are given these coordinates, which again we're going to write in a table. Okay? And we are asked, what do we notice? Hope that you have noticed that all the y coordinates in each pair is equal to 1. If we plot these points, we notice that all the points lie on a straight line which is parallel to the x-axis. Okay? So other coordinates which are also on this line are, for example, minus 1, 1, which is here, minus 1, 1. We have also, for example, 4, 1, which is here, okay, etc. All these points lie on this line. All coordinates which have 1 as their y coordinate lie on this line, okay. Now we are asked to write two coordinates Before we go to the next step, this line, of course, it is called y is equal to 1. Okay, y is equal to 1. So now we are asked to write two coordinates that lie on the line y is equal to -3. Again, we must remember that in every coordinate that we are going to write, there should be -3 as the y coordinate. Okay. -2, -3. Okay, which is here, -2, -3. I can have 1, -3. 4, -3. As long as the y coordinate is -3, they are correct. Okay? So these points should all have the y coordinate -3. Example, -4, -3. 2, -3. Okay? I have put those 2 points. And that line is called y is equal to -3. Because, again, it passes through where y is equal to -3. And it is parallel to the x-axis. Again, the equations that we saw were in the form of y is equal to c. Again, where c is any number, positive, negative, it doesn't matter. Okay? When the form of the equations is equal to y is equal to c, it will be parallel to the x-axis. Okay? So this line, for example, it is passing from y is equal to 1, 2, 3, 4, 5. So it is called y is equal to 5. Okay? Here it passes from y is equal to 3, so it is called y is equal to 3. Here below the x-axis, -2. Okay? So y is equal to -2. Another line which passes from y is equal to -5. Okay? So it is called y is equal to -5. Back again to the notes, page 5, question 9. Over here. I'm going to work out this question. Again, it's the same question that we saw on the presentation, but I'm going to work it out here so that you can follow what I'm doing. Okay, so plot these points on the graph. So -3, 1, -3, 1, -2, 1, 0, 1, 1, 1, and 2, 1. Okay, let me draw that line. So that line passes from y is equal to 1, so that is called y is equal to 1. What do you notice? All the y coordinates are 1. This equation of the line is y is equal to 1, as we have already so. Can you write two coordinates that lie on the line y is equal to -3? Yes, of course. Y is equal to -3. So this is x, this is y. So here in the y coordinate, I'm going to write -3. Same goes for the other pair of coordinate. And then I can choose any number for the x value. As long as the y coordinate is -3, it will pass from that line. So I'm going to choose -3 and 1. Okay? Draw the line on the graph. So I have to see where on the y-axis it is -3, which is here. So the line will pass from -3 and it should be parallel to the x-axis. So this is the line y is equal to -3. Okay? So as homework, you have question 8 on page 5, question 8, and question 10 on page 6. these two videos covered learning outcome 3.28. Hope that you understood them well, okay? And tomorrow, of course, during the next video, we'll start the next learning outcome. That's all for today. Bye for now.